Welcome to Chapter 2. In Chapter 2, we're going to see different scenarios, user mode and kernel mode. So before we start the scenarios, we will look at some user mode internals because we are going to see user mode scenarios first. And then we will see some kernel mode internals and then kernel mode scenarios. So before we start, I would like to highlight a couple of points here. We are not always trying to solve the problem. In production scenarios, more than often, we won't be able to solve the problem from collecting one set of dump. Probably you may have to collect logs, process monitor, some other logs, some other set of dumps, so on and so forth. So we are always trying to solve a complicated problem. Isolating the problem is one of the primary focus. If we can isolate the scope of the problem and then look into a smaller subset of the problem, typical divide and conquer. In the best case of a dump analysis, what we will get is a line of code in which you will find the problem. And in the worst case, you will be able to isolate the problem to a binary. And that binary may be from a third party, which you don't have source code or symbols. This case is very frequent when you do kernel mode debugging, dump analysis. Normally you end up a third party which you don't have any idea what is inside. And in certain cases, you will have to reverse engineer that binary to understand the problem and find out the further root cause. So why I wanted to mention this is when we see the scenarios in Chapter 2, in all the scenarios, we directly get all the data because we are artificially creating those scenarios. And we will find out the line of code which is causing the problem. But I want to set your expectation that that's not always the case in production. In fact, that's never the case in production unless it is the best case scenario which we are discussing here. We will see that when we discuss real problems in Chapter 3. You will get a feel of what I'm talking about. For each scenario we're going to see, we will have a whiteboard session to understand the concept, how the scenario and what is the fundamentals behind it. Then we will see the code, the source code which can potentially cause that particular scenario. And finally, we will troubleshoot the problem using different dump analysis techniques using WinDebug. Being said that, let's get into the user mode or essential user mode internals. This is a very brief user mode internal session. This topic itself worth a course. So what I'll be doing is I'll be giving you a glimpse of the user mode internals, probably not discussing a lot of details. And I'll be focusing the internals perspective to the debugging. So we'll be looking at the user mode internals from a debugging perspective mostly. So let's get to the whiteboard. We have seen this generation of a program. Let's review it. First, we have the source code of a program. So this is the source code, which is a text file. That text file, we pass it to a compiler. And the compiler generates the binary instructions. This compiler can other helper tools like linker, then some other programming languages can have runtime, interpreters, so on and so forth. This particular stage is considered as converting the human readable program into binary machine code. That is the role of the compiler linker box here. Now in Windows, this particular file is a portable executable file. We have seen executable files. They are normally exe files, DLLs, then sys files. So majorly they are in this three categories. We have seen exes. We have not developed sys. We will see sys files when we discuss kernel mode. Sys files are kernel mode drivers. We will discuss it later. Here we will see exes and DLLs. Exe is the file we have created when we wrote the Hello World application. In the case of Hello World application, we had the Hello World text file, which had the source code in it, all the C program, the hello world.cpp. And then we used Visual Studio. Visual Studio had all the compilers, linkers, and all the tools needed to generate the binary. Along with that, we have seen the Visual Studio generated the PDB files along with the binary PDB. Until this point, we have seen in chapter 1 all the details. Now these two files, in fact, let me focus on this particular file, the binary file. That is a file inside the disk. That file is not active. It's just like any other file. No special nature. It's a binary file which has ones and zeros inside it. Until now, it has no special meaning. This file will have special meaning when the operating system loads that program into the memory and start executing it. Let's see that in a different diagram. We have the executable file here. To load that executable into the operating system, first thing the operating system does is create something called address space. Address space in a 32-bit operating system is as big as 2 raised to 32. 2 raised to 32. Address space has nothing to do with physical memory or virtual memory or any memory for that matter. Address space is nothing but the maximum addressable location for that particular processor. It is just numbers or space. That's why the name address space. Well, let me write that down. Address space. This address space comes from 0 to F. 8FF. We need one more F. 0x. So this is in hex. This is also hex. This particular hex value is nothing but 2 raised to 32. The number of addressable bytes inside this address space is 2 raised to 32. So again, why 32? Because it is a 32-bit operating system and it is a 32-bit CPU. That is why the number 32. 2 raised to 32. Now, in Windows, the 1/2 of the 32-bit is used for user mode application. And the other half is used for kernel mode. Now, what is the difference between user mode and kernel mode? In user mode, we will have the code of all the normal application lies. Like Notepad, the Hello World application we have written, all the application we have so far written, all is going to be in user mode. In user mode, the programs has a less privilege. Only certain things it can do. Very limited things it can do in user mode. So if it wants to do something really advanced, it has to ask the kernel through something called system call. And only if the kernel permits, it will be allowed to do that. For example, to communicate to network, or to communicate to a file, or read and write from a file, or any device for that matter, display, the monitor, keyboard, any device communication. If the user mode code wants to do any device communication, it needs to request the kernel. That is the purpose of kernel. Kernel mode is called the privileged mode. This is the privileged mode. This has full access to the hardware. It can execute every instruction of the CPU, while the user mode can execute only a small subset of the instruction. For example, if I try to write into the segment registers of the CPU from user mode, I'll get an exception. We will discuss the interrupt next, what is an exception and stuff like that. We have the address space, which is 4 GB in 32-bit. The upper part of the address space, which is from 0 to 0x, 7 follows 7FF. This is the halfway till here. So this is the exact half, which is 2 GB. So this is going to be 2 GB. And this is going to be 2 GB. This is a configuration in Windows. This is not a limitation from the CPU. But this entire 32-bit is a limitation from the CPU. But this 2 GB, we can adjust according to the operating system. For example, in Linux, it's 1 GB, 3 GB. In Windows, also we have 1 GB, 3 GB combination based on some special switches. But normally it is 2 GB and 2 GB. We have the user mode and kernel mode address space. The kernel mode is the privileged mode. It has hardware access, and the user mode is non-privileged. All the normal application runs. If any application needs more access, like reading or writing into a file or connecting to a network server like Google, it needs to connect to the kernel using system calls. We were talking about loading this binary. First thing the operating system does is creating an address space like this for this particular program. So every program running inside the operating system has an address space like this. So if I go to Task Manager in Windows, and if I look at the Details tab, we can see a lot of applications. So these all are exe files. So a lot of these applications are running in the system right now. Every application has an address space like this. 64-bit address space looks slightly different, but very similar concept. All this application has an address space like this. In an operating system, a modern protected mode operating system, the purpose of this address space is to isolate one program from other. Address space is the entity which helps the operating system to isolate the programs from one another. When I say isolate, I mean that any program which is running in this user mode here cannot write into the user mode or kernel mode of other program. It can access memory only inside this sandbox. That way, all this program has different address spaces. All the address spaces of these programs are different. So they cannot interact each other unless the kernel is permitted.